Hello everyone, welcoming you to Shore Sir's classes. And today we are looking at the Azim Premji University MA Economics paper 2021. So consider the four different possible market structures for a homogeneous good with a constant marginal cost. So marginal cost is equals to some C. Assume that the demand function is identical in all the four cases. Case 1. Kurno or quantity competition with the two firms where price is P1. Number 2. Kurno or quantity competition with infinitely many firms where price is P2. Now, if you observe, what do we mean by Kurno or quantity competition with infinitely many firms? It's essentially same as perfect competition, right? Where the firms are competing with producing quantities. So the optimal will be over here, price equals to marginal cost, P2 equals to C. Coming to the third one, Bertrand or price competition within the firms where the price is P3. So here also, if you remember the Bertrand competition result that we have, that this is even known as the Bertrand paradox, that the competition between the firms will try to tend to push the price down, and ultimately in the Bertrand equilibrium the price will also be equals to marginal cost. So in the Bertrand equilibrium, P3 will be equals to C. And finally, the fourth one, Bertrand or price competition with infinitely many firms. Now, if you think about it, if the similar logic will follow that we had in the two firm case, because if there are a large number of firms trying to compete with prices, then definitely everyone will try to push the price down to get a higher market share, and ultimately in this case also the Bertrand equilibrium will be P4, which is equals to C. P4 is equals to C. So now what the options say, which of the following are true essentially. So if you look at the options, the first thing which we directly obtained is P2 is equals to P3 is equals to P4 is equals to C. This is for sure. So it can be either option A or option B. C and D will not be there. So now the question is if P1 is also same to C. Now if you remember, the answer is no, but we can also work that out and check. So we have two firms. Okay, so two firms. Let's say firm 1 producing output Q1, firm 2 producing output Q2. Okay, the demand function is something like price equals to A minus B of Q, where Q is basically the aggregate of the two things that is produced. Marginal cost of 1 is equals to marginal cost of 2 is equals to C. Correct? So identical marginal cost. And we are in the Kurno setup. So if we take form 1, then what will be the profit looking like? It will be P into A minus B times Q1 plus Q2. This is the price. You will multiply this with the quantity. This is your total revenue minus the total cost, which is C minus Q1. And what will the firm will do? It will try to choose the level of Q1 that maximizes pi 1. So this will be basically your A minus B times Q1 plus Q2. This is there, plus Q1 times minus B minus C is equals to 0. Okay, so this is how the expression will look like. So A minus BQ1 minus BQ2 minus BQ1 minus C is equals to 0. So 2BQ1 plus BQ2 is equals to A minus C, right? This is how it is. Now since the marginal costs are same, so the quantities will be identical. So Q1 star will be equals to Q2 star. That means 2B Q1 star plus B times Q1 star is equals to A minus C. So 3 times B Q1 star is equals to A minus C. That means Q1 star, the optimal level, is equals to A minus C by 3B, which is same as Q2 star. So what is the optimal price? It is A minus B times Q. So that is Q1 star plus Q2 star. That is A minus B 2 times A minus C by 3B. So this B and B will get cancelled. So ultimately we get A minus 2 by 3 times A minus C. So that is 3A minus 2A plus 2C divided by 3. So that is A plus 2C divided by 2, 3. So that is definitely greater than C. Okay. So that means your P1 will be greater than C. This is your conclusion. So that means the options which match is option number B. P1 is greater than P2, which is same as equals to P3 and P4. Okay, so that is option number B for question number 7. So now moving on to question number 8 of the Azim Premji University M Economics 2021 paper. A person's utility function over the amount of rice in kg denoted by R and the amount of dal in kg denoted by D is given by this Cobb-Douglas setup. A person already has 5 kgs of rice at home that can be consumed but not sold. Now the person heads off to the market to purchase rice and dal with a budget of rupees 100. Now his utility function can be written as U of Rp, D, which is another Cobb-Douglas setup, where Rp denotes the amount of rice purchased and the R denotes the amount of rice which is consumed, which is Rp plus 5. If the price of rice is rupees 1 per kg and the price of dal is rupees 2 per kg, what is the amount of rice that the person will consume? Okay, that means it's a straightforward information based question. So your utility function, so just look at the variables. What are the things that we need to determine? It is Rp, the amount of rice that will be purchased, and the amount of dal. Okay, the agent has an income of rupees 100. Price of rice is given to be rupees 1 per kg and the price of dal is given to be rupees 2 per kg. Okay, what is the utility function? U of Rp comma D is equals to Rp plus 5 to the power 0.4 and D to the power 0.6. So what is the budget constraint that the consumer has? M is equals to price of rice into the amount of rice that he can purchase with that plus the price of dal into the amount of dal that he can purchase. So that is M is equals to 100, PR is 1, so RP plus 2D. So what is the objective of the consumer? We want to maximize U of RD, RP, not RD, subject to this constraint. That is 100 is equals to Rp plus 2D. Okay. So now we know what the optimal will be looking like. At optimal, we'll have marginal rate of substitution, which is equals to price of rice by price of dal. This is how the optimal will look like. So let us compute the MRS. So we can simply take a monotonic transformation over here. So if I take a log of this, so what we'll get? It will be 0.4 times log of Rp plus 5 plus 0.6 times log of 3. So let us say I denote this by V. So what will be the MRS? It will be dV by del Rp divided by dV by del D. That is 0.4 divided by Rp plus 5 divided by 0.6 divided by D. So this will become 0.4 times D divided by 0.6 times Rp plus 5, and this at optimal should be equals to half. So 0.4D by 0.6 times Rp plus 5 should be equals to half. Now if you look at the question, what are we asked to actually obtain? What is the amount of rice that the person will purchase? So essentially it is Rp that we need to find, the optimal value of Rp. So over here what we'll do, we'll replace in values of D. So that is half times 0.6 by 0.4 divided by Rp plus 5. So D is equals to half into 6 by 4, so that will make it 3 by 2. So Rp plus 5. So that is 3 by 4 Rp plus 5. What's the budget constraint? From budget constraint, 100 equals to Rp plus 2D. So we just replace the value 100 equals to Rp plus 2 times 3 by 4 times Rp plus 5. So that will be 100 equals to Rp plus 3 by 2 times Rp plus 5. So 100 is equals to Rp plus 3 by 2 Rp plus 15 by 2. So 100 minus 15 by 2 equals to 5 by 2 Rp. So that will imply 185 by 2 equals to 5 by 2 Rp. So 2 and 2 will get cancelled. The optimal amount of Rp, which is Rp star, is 185 by 5. So that will go 3 times and this will go 7 times. So Rp star is equals to 37. And if you look at the options, that is option number A in your set. Okay. Okay, so now let's move on to question number 9 of the Azim Premji University M Economics 2021 paper. So consider the following two-person simultaneous move game, and the table above displays the payoff matrix between player 1 and player 2, who chooses strategies between small d and small h, and player 2 chooses between capital D and capital H. So if I can just draw a line to make it like look like a proper thing. So this is player 1, this is player 2. The first number in each cell denotes the payoff of player 1 and the second number denotes the payoff of player 2. So the Nash equilibrium will be which of the following? Okay, so let's start. Suppose let us begin with assuming that player 2 chooses capital D. So in this situation, player 1 has two options, either to go for small d, which gives him a payoff of 2, and either go for small h, which gives him a payoff of 3. So he will choose h. Okay. Now go the other way. If player 1 is choosing h, then what will player 2 do? If he chooses capital D, he will get a payoff of 4, and if he chooses capital H, he will get a payoff of 3. So he will go for choosing capital T. And there you go. This is the Nash equilibrium directly which we obtain. So that is small d and capital D. That is option number A in your set of options. Okay, so now let's move on to question number 10 of the Azim Premji University M Economics paper 2021. A firm has three components of its production cost. It has a fixed cost CF of 10 units that is independent of the production process. It has raw material cost CR that varies linearly with the quantity produced. It has a labor cost CL that varies as the square of quantity produced. Hence, the total cost function is C equals to CF plus CR plus CL. Then the marginal cost of the firm will be with the option. So let us first understand how will it look like. The fixed cost is 10. Cost of raw materials is varying linearly with the quantity. So that is basically some A times Q. And the cost of labor varies with as a square of quantity. So that is B times Q square. Right? So it's a quadratic function. So what is the marginal cost? It is dC by dQ. So that is A plus 2 times dQ. Right? So as Q increases, marginal cost also increases. So it is increasing. And if we just differentiate this further, d of marginal cost divided by dq, we get 2q, 2b, which is a constant. So that means the marginal cost is increasing as a constant rate with the increase in production level. So your option is number B. Thank you.